In this video, you will learn about prism layer options in a hybrid mesh in ICEM CFD. A generic CFD model of a helicopter body is used. I'll start by setting global mesh parameters for scale factor and max element size. For prisms, I let the initial height and total height float while setting height ratio and number of layers. And to avoid stair-stepping, I set a prism height limit factor and enable auto reduction. Surface mesh parameters are used to refine the mesh on the helicopter body. Box Select is an easy tool to select all required surfaces. I need significantly smaller triangles on the body. I'll start with a simple tetrahedral mesh. The octree process is relatively quick, it produces a good mesh, and I can use it as a consistent starting mesh to compare options. The mesh is examined visually and statistically to be sure that it meets solver criteria. Prism mesh parameters were set, but not yet used. I use the Part Mesh Setup dialog box to enable boundary layer prisms and to verify the applied parameters on the helicopter body parts. Now, when I regenerate the mesh, Create Prism Layers is enabled. The post-inflation process first computes the same TET mesh as before, then replaces TETs with prisms near the surface of the selected parts. In a typical workflow, I would now examine the mesh visually and statistically to be sure that it meets my solver criteria. An alternative prism layer option uses the pre-inflation, fluent meshing process. For consistency, I'll regenerate the starting TET mesh. The pre-inflation process creates prisms from the surface triangles, then fills the remaining volume with tetrahedra. Hex core fill is also an option. Visually, the pre-inflation prism process gives smoother layers. The mesh statistics should be checked to be sure the solver criteria are met. If further refinement is needed, I can use the Part Mesh Setup to adjust many meshing parameters on a part-by-part basis. For example, I can set smaller surface mesh size on the leading and trailing surfaces of the helicopter body. I can also adjust the prism height limit factor to allow thicker layers on some parts and thinner on others. I'll recompute the simple tetrahedral mesh to provide the triangular surface mesh needed for the pre-inflation prism process. And to verify cell size changes. The hybrid mesh is calculated using the fluent meshing pre-inflation process. For most situations, pre-inflation gives faster results with smoother prism layers. Although it is typically slower, the post-inflation prism option is available for those situations requiring a more robust mesher. For example, if enabled, stair-stepping in thin regions may be reduced. Alternatively, enable curvature proximity refinement along with auto reduction to reduce stair-stepping in thin regions. This concludes the Prism Mesh Options and ICEM CFD video.